Hi everyone, welcome back to the channel. Today is the 5th episode of Classic Coding Interview Question, and the question is search in rotated sorted array. And before we start, don't forget to subscribe to my channel. I'll be constantly solving good and classic LeetCode questions with clear explanation, animation, and visualization. Now let's look at the question. In this question, there's an integer array nums which is sorted in ascending order with distinct values, no duplicates in the array. But prior to being passed to your function, the nums array, it is rotated at an unknown pivot index. And rotated means that at a pivot index, all elements before it will be moved to the end. So for example, for the array 0, 1, 2, 4, 5, 6, 7, it might be rotated at pivot index 3. So the elements before it, 0, 1, 2, will be moved to the end. And the resulting array is 4, 5, 6, 7, 0, 1, 2. And given the rotated sorted array nums, we have to return the index of target if it is in nums. Otherwise, return -1. And here's a strong requirement of this question, that we have to write the algorithm with log time complexity. And this is also a big hint of what algorithm we should use. For example 1, the input is 4, 5, 6, 7, 0, 1, 2, and target is 0, and we return the index of 0 in the array, which is 4. And for example 2, for the same nums array, and target 3, which is not in nums, so we will return a -1. And for example 3, nums array is 1, target is 0, it's not in the nums array also, so we will return -1. Data constraint for this question, the length of the nums array can go up to 5,000. And here it emphasizes again that all values of nums will be unique. And to search a target value in the array, we can always use a naive approach, which is linear search. That is, searching from the first to the last element and see if target exists. And this approach will be linear time complexity. And the key characteristic of the input of this question is it is rotated sorted. And to search in the sorted array, we should always think of using binary search, which is a divide and conquer algorithm with log time complexity. But binary search is for searching a fully sorted array. And how do we perform binary search on a rotated sorted array? And the trick is that first we have to check which part of the array is sorted. And if target value is not in the sorted half, then it must be in the other. And this will be more clear when we see the code in action. Okay, so the key characteristic of a rotated sorted array is that if we stand at the middle element, then there must be at least the left or right half are sorted. So for example, if we stand at the element 7, then the left half is sorted. Then we can check like if target is in the left half or not. If it is not, then it must be in the right half. So with this logic, we can write the binary search algorithm with some modification. So at the beginning, the left and right pointer will point to the first and last element in the array. And the condition is while left is smaller or equal to right, and then first calculate the middle index. And if the middle element in the nums array is equal to target, then we will just return the index. But if nums mid is bigger or equal to nums left, which means that the left half of the array is sorted, then we will further check that if target is within the range of the left half of the sorted array. If it is, then we will update the right pointer to mid -1. Otherwise, update the left pointer to mid +1. And vice versa, if the right half of the array is sorted and target is within the range, then we will update the left pointer to mid plus 1. Otherwise, update right to mid minus 1. And if we could not find target in the array, then we will just return a -1 at the end. So first, mid will point to index 3, and the value is 7. It is not equal to target 0. And next is to compare the left and middle element. So nums mid is bigger than nums left. So it means that the left half of the array is sorted. But is target 0 within the range? No, it's not. So it means that target 0 must be in the right half of the array. So we will update left to mid plus 1. And now left pointer will point to index 4. And now it's the next round of binary search. So mid now will be pointing to index 5. And then compare nums mid and nums left. And nums mid is bigger than nums left, so it means that the left half is sorted. And is target 0 within the range? Yes, it is. So we will update right to mid minus 1. And now left and right pointer overlap. So mid will be also pointing to the same index. And the value is exactly the target 0. And now we found target, and we will return its index 4. And this will conclude the algorithm. Finally, let's review. So the naive approach of searching a specific target element in an array is linear search, but its time complexity is linear because of n. And to do better than that, since the input in this question is a rotated sorted array, we can use a modified version of binary search. And the intuition is first check which part of the array is sorted, so we can further check if target value is in the range of the sorted half. And if it is not in the sorted part of the array, then it must be in the other. The time complexity of this approach is big O log n, a divide and conquer approach. And space complexity is constant. No extra space is needed. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.